Hello, good afternoon. My name is Daniel Alfaro, and this is the video explaining the exercise of the exam. As you can see, the first of this is to find the next derivative. For this, I will use the power rule since being a small multiplication, because in my opinion is faster. But first, we will start by multiplying the whole equation. So for this, we start multiplying the u's. U raised to the 2 times u raised to the 2 is equal to u raised to the 4, and u raised to the 2 times 3 it's equal to 3u raised to the 2. We continue with the minus 4u, that it's equal to minus 4u times u raised to the 2, it's equal to minus 4u raised to the 3. And finally, we obtain minus 12u multiply the minus 4u times 3. Well, once this is done, we order the values. So we start with the u raised to the 4, and we continue with the minus 4u raised to the 3 plus 3u raised to the 2, and finally the minus 12u. So when we final do this, we can start with the process of the derivation with the power rule. The formula of the power rule is this one. It's nx exponent n minus 1. So we start, give me a sec. So we multiply the exponent by the number it's next to the variable, and then we subtract 1 to the exponent. So for example, we multiply 4 times 1 because you have a 1 next to. So for u, and the exponent is 3 because we subtract 1. And we do this for all of our values. So the next one is 12u raised to the 2 and 6u raised to the 1, but it doesn't necessarily put the 1 like exponent. So finally we put 12 because 1 minus 1 in the exponent is equal to 0, so the variable is eliminated. Hello again. For the next exercise, I will continue using the power rule for convenience. And as you can see, in this case, we have some square roots and fractions. So in order to solve and find the derivative of this function, we first convert the roots to fractional numbers. So for example, the first one, we convert, 2 over x raised to the 5 over 4. We continue with the same, with the 1. So 1 over x raised to the 1 over 2, and the 3 over x raised to the minus 1. We don't touch yet because it doesn't is not as a root, so don't touch yet. X minus 1. So once this is done, we need to convert the numbers to integers. So we convert the positive exponents to negative to put them as numerators. So for do this, we basically takes the x raised to the 5 over 4 and convert negative and put with the 2, that it's equal to 2x raised to the minus 5 over 4 minus 1. We do the same with the 1 and the over 1 of raised to the 1 over 2, that it's equal to x minus 1 over 2 plus 3x raised to the 1. Why? Because the negative exponent in this case, that it's 1, it's in the denominator. So when we change to the numerator, the exponent become in positive, so it's converting 3x basically. And well, once this is done, we start with the above mentioned procedure with the power rule. So we start multiplying the exponents by the numbers next to the variable and subtract the 1 from the exponent. So we start like 2 times minus 5 over 4, that it's equal to minus 10 over 4, that it's equal to minus 5 over 2. X raised to the, we take the minus 5 over 4 and we subtract 1, that is, we can use 4 over 4 because it's the same than 1, that it's equal to minus 9, 4. So the exponent for this part is x raised to minus 9 over 4. So the next value, that it's 1, x raised to the minus 1 over 2, it's the same. We take the minus 1 and multiply by the minus 1 over 2, that it's equal to 1 over 2, positive. And to the exponent, we just take the minus 1 over 2, that is the exponent, and we subtract with 2 over 2, because it's equal to 1. So we obtain minus 3, 2 over 2. And our exponent, it's equal to x raised to the minus 3 over 2. And for the 3, well, we use the same, but in this case, the x don't have an exponent, so just have a 1, so it's equal to 3. So our derivative of this function, it's equal to, let me check the number that we obtain, and that I obtain, and it's minus 5 over 2 x raised to the minus 9 over 4 plus 1 over 2 x raised to the minus 3 over 2 plus 3. So we need to change the negative exponents to positive. So for do that, we just put the numerators as denominators and we change the sign. So for example, minus 5 over 2x raised to the minus, sorry, 9 over 4 without the minus, because it's positive because we changed the position. And do the same with the 1 over 2x raised to the minus 3 over 2. That is equal to 1, 2x, 3 raised to the 3 over 2 plus 3. So for the last function, I will use the product rule, and for this, I will divide the equation in 2, where 1 over 3x plus 2 will be my f, and 1 over 3x plus 2 raised to the 2 will be my g. So when this is done, we will use the product rule formula, which is this one, is the first equation times multiplied by the derivative of the second plus the second equation multiplied by the derivative of the first. So for this, we need to see what is what. So f is equal to 1 over 3x plus 2, and g is equal to 1 over 3x plus 2 raised to the 2. That it's equal to 1 over 9x to the 2 plus 4 over 3x. It's a 3. I'm sorry, okay. Over 3 plus 4. And then we obtain their derivative. So it's first f is 1 over 3, and g it's 2 over x plus 4 over 3. So with this, we start by substituting the value with the respective letters. So we start with the f and g and the derivative of g, that it's 1 over 3x plus 2 multiplied by 2 over 9x plus 4 over 3. And we continue with the second ones, plus g and derivative of f, that it's 1 over 9x2 plus 4 over 3x plus 4 multiplied by 1 over 3. So we start multiplying everything to obtain our derivative of our function. So to start with this, we multiply 1 over 3x times 2 over 9x, that it's equal to 2 over 27x2, and we continue with every value. So the second one is 4 over 9x, the next is 4 over 9x, and the next is x over 3. We continue with the next value, that is 1 over 9 raised to the 2 times 1 over 3, that is equal to 1 over 27x2 plus 2 plus 4 over 9x plus 4 over 3. So we have that. Once that we have that this, we only need to add or subtract the values that are similar. So we start with this one and this one, that is equal to 2 over, that is equal to 3, 27x raised to the 2, that is equal to 1 over 9x raised to the 2. We continue with the next one, that is this, and this are this. And this are equal to 12 over 9x, that are equal to 4 over 3x. And finally, we obtain the last number, that are both of them, and obtain, that is adding these numbers are 12 over 3. I'm sorry, I confused myself. That is equal to 4. So if we combine every result, and every result, we obtain our final derivative, that it's equal to 1 over 9x raised to 2 plus 4 over 3x plus 4. Thanks.